All right, let's talk about something that drives developers absolutely nuts. You've got a problem, you show an AI a screenshot of your code, and the answer you get back? Completely useless. Why does this happen? Well, we're about to break it all down. You know exactly what I'm talking about, right? You take this perfect, crystal clear screenshot of your code, you even point to the error, and you ask the AI to fix it, and what you get back is this generic guess that totally misses the point. It's so frustrating. So, what is the AI really seeing?
Okay, so the first thing we've got to get our heads around is that an AI doesn't see your screen the way you and I do. There's this huge disconnect between its vision and ours, and it all starts the second it processes that image.
And this slide right here, this gets to the heart of the very first problem. On the left, that's your beautiful pixel-perfect 4K screenshot. But on the right, that's often what the AI is actually working with. See, to be efficient, these big models have to shrink images way down. And when that happens, all that crucial detail, the fine text, the subtle UI elements, it just gets blurred into a mush. So this whole disconnect really boils down to three big things. First, as we just saw, is that image downscaling. It just kills the details. Second is what's called semantic understanding. The AI gets the gist, it knows it's looking at, say, Python code, but it has no chance of telling a colon from a semicolon in that blurry mess. And third, it has zero positional precision. It kind of gets that the button is near the text, but it has no idea that the button is off by exactly 3 pixels. So here's the bottom line. The AI is pretty good at figuring out the what, the general concept on the screen, but it's really, really bad at the specific where, the exact pixel location, and the technical how, the actual code that created that exact pixel in that exact spot. And that leads us right into the big central idea of this whole explainer. It's something we're going to call the abstraction gap. Think of it as this massive, massive chasm between the pixels the AI sees and the intent that you, the developer, actually had in your head. So what is the abstraction gap? It's the AI's struggle to work backwards. It sees the final product, does pixels on the screen, and then it has to guess. It has to try and figure out the one specific combination of code that created it, out of literally thousands of possibilities. Let's make this super concrete with a simple, everyday example. We've all coded a million of these, right? A simple blue button. How hard could that possibly be for a super smart AI to figure out? Well, this right here is the abstraction gap in action. That one simple visual result, that blue button, could have been made by any of these methods, and a bunch more. Just from looking at the pixels, there's no way for the AI to know if you used plain old HTML, a fancy React component, or a utility framework like Tailwind. It's just taking an educated guess, and it's often wrong. And this quote, wow, it just hits the nail on the head when it comes to debugging. The AI sees your button is misaligned, but it can't know why. Is it a margin issue? Is it padding? A flexbox error? The visual evidence alone gives no definitive clue, leaving the AI to just throw random suggestions at you. And if you thought that was tough, oh boy, let's talk about the ultimate stress test for an AI's visual understanding: generating scalable vector graphics, or SVGs. This is where that abstraction gap we talked about becomes a massive canyon. I absolutely love this quote because it just captures the challenge so perfectly. You see, SVG isn't just code. It's a super precise mathematical description of a visual thing. For an AI to get it right, it has to be a brilliant coder, a mathematician, and an artist, all at the same time. If it fails on even one of those, the whole image just breaks. This poet versus architect analogy is probably the best way to think about it. An LLM, at its core, is a poet. It's probabilistic, it's creative. If it writes an awkward sentence, you can still probably understand what it meant. But SVG is an architect's blueprint. It is deterministic, logical, and brutally strict. One misplaced character and the entire structure collapses. There is no partial credit in SVG. For a perfect example, just look at the SVG path element. It's basically its own little programming language inside of SVG just for drawing lines and shapes. So to create something as simple as a wavy line, the AI can't be poetic about it. It has to generate a perfectly precise sequence of mathematical commands. A single wrong number in that sequence, and you don't get a smooth wave, you get a jarring, broken glitch. The big takeaway here is that to master something like SVG, An AI needs what you might call a mental canvas. It needs to remember what it just drew, understand how different shapes are grouped and layered on top of each other, and it needs to plan ahead. And this kind of stateful, long-range strategic planning is, frankly, a huge weakness for most current models.
Okay, so we've diagnosed the problem. We get the downscaling, the semantic limits, and this big abstraction gap. So now for the important part. How do we fix it? How do we actually bridge that gap and get the AI to give us the useful answers we're looking for?
The solution is actually pretty straightforward. The key is you have to become the bridge. You can't rely on the screenshot alone. You need to be the one who manually provides all that missing context that connects the pixels the AI sees to the intent you have in your head.
And the absolute best way to do that is with a technique we're going to call the golden trio. It's 3 simple steps. First, an annotated screenshot. Literally draw an arrow or circle the problem. Second, paste in the relevant code snippet, not your whole app, just the part that matters. And third, provide a clear description of your goal. With these 3 things, you're combining the visual, the code, and your intent into one perfect package.
Just look at the difference here. On the left, you've got the bad prompt. My button is misaligned. See screenshot, fix it. We've all done this when we're frustrated, right? But it gives the AI zero context to work with. Now look at the good prompt on the right. It names the component, it states the goal, vertically centered, and it provides the visual, the code, and the framework context. The difference in the result you'll get is just night and day.
So that leaves us with this one big, final question to chew on. Today, we've seen that AI thinks more like a creative poet than a logical architect. But as these models get better and better, will they eventually learn to think like an architect? Will they develop that precision? Or will the human developer always be needed to act as that crucial bridge between the visual world of pixels and the logical world of code? It's definitely something to think about. Thanks for watching.